Hello everyone, welcome back to Kira Cloud Hub. So a continuation of the Cloud Practitioner Bootcamp series. And where are we at the moment? So right now we are in module 5, who manages the servers in the cloud. And yeah, compute without a care. We started out with an introduction to cloud, the AWS global infrastructure, identity and access management in AWS. Our last video was how to set up our network. So AWS networking. Now servers in the cloud. So what type of compute services do we have and how can we utilize them in the cloud? So to get started, our module server who manages the server within the cloud, compute without a care. What are we going to cover? So we'll cover an introduction to Elastic Compute Cloud, what is EC2, elastic load balancing and auto scaling within the cloud. So we'll cover the concept of what are the elastic load balancers available in AWS, what is an auto scaling group. We'll touch on some of the container services we have in AWS Lambda, function as a service, and then wrap up with some other additional compute services that you might need to know in the exam, but at a very high level, batch and light sale. So to get started, we'll get started with Elastic Compute Cloud, EC2. So Elastic Compute Cloud, this is one of the most crucial and widely used services within AWS. Now think of it as AWS solution of renting the compute power that you need as and when you need it. And what are some of the core capabilities of EC2? So we get virtual machines whereby we are able to rent servers on demand. And this is just like, leasing a powerful computer over the internet that you can configure for different workloads. We also get data storage with the concept of EBS. We'll discuss that in a moment. So with Elastic Block Store, EBS, we can attach persistent storage to our virtual machines. It's like having a portable hard drive that you can add and remove as and when you need to. We have the concept of traffic distribution, that is ELB, elastic load balancing, which we'll also cover. And this allows traffic to be evenly distributed across multiple instances. Now picture an ELB as a traffic director, just making sure requests are distributed efficiently to our virtual machines. We'll also cover that concept. And the other capability of EC2 is auto-scaling. And here we have the concept of ASG, auto-scaling group, which we'll cover again. And now we are trying to automatically adjust the number of running instances based on demand. It's like adding some extra highways, when traffic gets heavy. So EC2 is fundamental because it provides a practical model of understanding how cloud services function. It's flexible, scalable, and on demand, and mastering the EC2 components will give you a solid foundation in cloud computing and AWS. So speaking of EC2, virtual server, nothing much to say about it. How do we launch one? So the first thing that we get started with is the name and tags. Begin by naming your server clearly for identification. And tags are key value pairs to help us organize our AWS resources. For example, the key could be environment. Which environment does this EC2 instance belong to? Is it prod? Is it the dev? Is it a test? Okay. Or a key could be the owner. The owner is Kira, or the project. So key tags just enable us to efficiently organize our resources, and this could help also with billing purposes, where you want to see maybe the instances which belong to the prod environment, how much are they costing me. We have the application and operating system image. Now you have to select the appropriate AMI. This is what we call the Amazon machine image based on your application requirements. So for example, we have different options: Linux, Ubuntu, Windows, Mac. So consider the use case. Amazon Linux is good for web servers. Windows is good for .NET applications. Ubuntu is good for open source software development. Let me know what Mac is good for. But yeah, so that is the Amazon machine image, which contains the application and the operating system image. We have the instance type. You have to choose the instance type that fits your compute power needs. So we'll get more into instance types. And here we are selecting based on CPU. How much does this server have? What is the RAM, or how is the performance? Now we have different categories that we'll look into when we get to instance types. Key pair. A key pair is used for securely accessing your server. So maybe you want to specify a key pair for secure SSH for Linux or Windows RDP. Yeah. So if you create a key pair, it downloads the private key that is only available once. We'll see that in our demo. No worries. The fifth thing we set up, network settings. So in the last video, we discussed how to set up your network. So you have to place your server inside a VPC and subnet. So you have to set up the VPC and the subnet to place your instance in the correct network environment. You also need to decide on things like, do you want your instance to have a public IP assigned to it? So we select public IP for internet access. And also we have things related to security groups. Still from networking, if you want to be familiar with that, go and watch my last video. So you need to set up your firewalls, the appropriate firewalls, and security group will come into that. Number 6, storage. So you have to attach some storage volumes based on your application's data needs. Now we have different volume types, which we'll discuss, whereby we have the EBS, Elastic Block Store for persistent storage, and an instance store for temporary storage. We'll discuss that later on. And then we have some advanced details. Advanced details, we can set up things like user data scripts. We'll see what a user data script is in a moment, which is used to automate our instance configuration, like installing software or configuring services when our instances launch. There are other things in advanced options, like setting up IAM roles. We discussed IAM module 3. So we have to set up things like IAM roles for permissions, monitoring our settings, and also stopping behaviors. How do you want your EC2 to be terminated, or so on. And after that, the last step, of course, you review all your configured settings before launching to ensure accuracy. So it's important to always make sure you double check your configurations just to prevent issues post launching your EC2 instance. Now, I mentioned something about user data. This is not data about the users under the advanced details. So what is user data? User data is a feature that allows us to automate the initialization process of our instances. So we are automating initialization by how are we going to do this? We are going to bootstrap. And bootstrapping means executing commands or executing scripts when an instance first starts. So the user data script executes only once at the initial launch of the instance. So this means that any setup tasks or any installation, remember we are setting up scripts, any installation occur immediately after booting up your instance. The script always runs with root user privileges, God mode, and this is what allows it to perform administrative tasks. This means that user data script, within that user data script, we can install software and make system level changes without needing any additional permissions. So some of the automation tasks that can be done using the user data script, we can install any updates. So ensure our system has the latest security updates or security patches and features. We can install software with the user data script. So pre-install necessary applications, things like web servers, these like database engines, we can pre-install them. We can use the user data script to download maybe some configuration files or scripts from the internet, to set up our environment. Or we can just run some custom commands that we need to run, any valid shell commands to configure the instance as we need to. So let's go ahead and do an instance demo, launch ourselves an instance. So we are going to launch two EC2 instances, one for Linux, one for Windows Server, and see how different they are. So I'm in my management console onto EC2, and I want to launch an instance. So I want to change my region and launch this in Oregon. So launch an instance. I'll first start with a Linux instance. If you remember, step 1, give it a name. So I'll say maybe my Linux server. And choose the operating system. So, and operating system images and application. That is what we call the Amazon machine image. Now we have some that we can use to quick start, the popular ones like Amazon Linux. Maybe I want a Mac OS operating system, an Ubuntu or a Windows, but you can browse more AMIs and you'll see different types of AMIs. So the quick start ones, the commonly used ones, around 45. So the Amazon Linux, the likes of Mac, the likes of Windows, Ubuntu, let's see. Yeah. And then we have, you can create your own AMIs. We'll see how to create our own AMIs. You can build AMI, you can use AMIs from the AWS marketplace. And these are the AMIs provided by, third-party providers who are AWS partners. So we have different types. For example, you want to set up a Palo Alto firewall, or you use Palo Alto or you use Fortinet and you want to set that up as quickly as possible, you can utilize the marketplace AMIs, and these ones are trusted by AWS, Cisco, Meraki, and so on and so on. And now we have the community AMIs. So you can decide that your AMI is public. So we have private AMIs or public AMIs. So these are just public AMIs from users and they are not trustable. So you should, anyone can publish an AMI, and these ones are not basically, trusted or verified by AWS. So you have to be really careful when using the community AMIs. So I'll quick start mine. I'll choose a quick start one and launch the latest Amazon Linux AMI. So I'll select Amazon Linux 2023. And we have the details over there. So a general purpose Linux based operating system that comes with 5 years of long-term support, and so on and so on. So the instance type, remember we mentioned about selecting the flavor that fits you. So we have different instance types, which we'll compare in the next when you go over to the next slide. So I'll go with the default one, the T2 Micro. We have different types from different families, and you can assume the T2 Micro compared to the T2 Large. So the T2 Micro offers 1 virtual CPU, 1 gigabyte of memory. The T2 Large offers 2 virtual CPU, 8 gigabytes of memory. So depending on your requirements, choose the instance type that works for you. I'll go with the free tier one, T2 Micro. You need to create a key pair if you need to securely connect to your EC2 instance. So how to create a key pair? Just create a new key pair and give it a name. And so RCA type. So for those people who have, Linux, if you're going to use to remotely SSH using OpenSSH, you can download the .pem file. If you are going to use PuTTY for the Windows users, this is a tool that you can use to securely log into your EC2 instance. You can download a PPK file. So I'll download a ppk file for now for use with PuTTY and create that key pair. And network settings. So you have to edit your network settings. Choose the VPC where you want to launch your server. Choose the subnet. So right now I'll go with the default, but from networking, if you created your own VPC, you created your own subnet, you can select exactly where you want to launch your instance. So for the subnet, I can go with maybe the availability zone 2A in this case. And auto assign public IP, I need it to be publicly accessible instance. So I'll select auto assign public IP, and then for a security group. So you can create a security group or select one that you already created. I'm going to create a security group. So this is for my Linux server. And I want to allow specific roles. So a description, what does this security group do? So I'm going to allow SSH access and HTTP access, because I'm going to host a web server in that EC2 instance. So I want it to be accessible via HTTP. Cool. So the first rule allows SSH from anywhere. Not best practice. You can choose to decide custom or your own IP. So I'll allow anywhere for now, and then I want to add a security group that allows HTTP access. So I will add a new role, and this will be HTTP port 80 source type anywhere. So any HTTP traffic is allowed. Cool. And then you can configure your storage settings. So this is just selecting, how many GB do you need for your root volume. You can attach multiple volumes for your storage. And then in the advanced details, more details you can set up for your specific EC2 instance. So let's see what you got. So here's where you can set up an IAM role if you have created one. You can set up things like your shutdown behavior, your stop and hibernate behavior, if you want to enable termination protection. That means that no one can terminate your instance unless you disable that. Placement groups, so lots of things. I will also discuss about purchasing options, and we'll see what purchasing options we have available just within this slide. So now I'm only interested in the user data section. So with the user data, remember it's a script that we can use to boot up our EC2 instance. So I'm going to add a user data over here. So this is my user data script. I'll share it as part of the links. So this is a script that does a couple of things. So for Amazon Linux 2023, first it will do an update to all packages within the system. It will install Apache web server and then install PHP and necessary extensions. So I'm trying to install software during boot up. It will install Telnet for connectivity checks. And then we are going to start and enable the Apache web server, so the HTTPD service. Move on to the web root directory, and download the web application. So wget, we are doing some, bash scripts, some Linux commands. So I'm downloading details of the web application from this specific site. Yeah, so that is my user data script. When I launch this instance, I expect all this to have happened. And because I am enabling and starting my web server, if I copy the IP address of my EC2 instance, I expect to get a web page back. So I'm going to copy that under the user data script. And if everything is okay, I can go ahead and launch this instance. So that is my Linux web server. I can go ahead and quickly launch a Windows one. So launch instance. I'll use the same settings, just that for now, I'm going to use the Windows operating system image, but I won't make it a web server. So it will be just a Windows server for the purpose of the demo on how to RDP into it. So Windows server, I give it a name. The OS image, now I'm going to select Windows for now. So Windows Server 2025 base. Instance type, I leave it as default. So with the instance type, T2 micro is okay. I'm going to create a key pair, and the key pair for Windows instance is not used for SSH, but to create a password. We'll see that in a moment when we get to the SSH demo. So I'm going to create a new key pair. This will be a .pem file, pj Windows key. I'll create a key pair. So that has to be a .pem file, and it's used to decrypt our Windows password. Network settings, you can go ahead and edit. So I leave the default VPC and also select the availability zone 2A. Auto assign public IP, no worries, and then I'll create a security group. Now this security group should contain the rules that I need. So this will be my PJ Windows Server SG security group. And for this one, I just only want to allow RDP access because I need to be able to remotely access my Windows server. Cool. So the rule that I only need to allow RDP in this case. So I can see an inbound rule RDP from anywhere. I don't mind, even though best practice, you can just change it to, your own IP. Okay, so maybe, RDP from my own IP. I'm the only one who can, remotely access this Windows server. I leave storage as default and launch this Windows instance. Okay, so let's check the first Linux server that we launched before. So its status check have all passed. We can view the details section, the instance summary, the instance ID, its public and private IP addresses, a public DNS, the instance type, which VPC it belongs to, its subnet if it has an IAM role attached to it. So you can always view the details section, status and alarms, any status checks. So it passed the system status check and also the instance status check. Any metrics you have set up, you'll see over here. So those are the CloudWatch metrics. We'll cover CloudWatch later. Security, things like the firewalls attached, the security group, what roles do these firewalls have, networking, about the IP addresses and the VPC and the subnet, storage, what is this volume attached to this? Is it a root volume or so? And yeah, so since we use the user data to install a web server and an application, let's copy the public IP and see what we get. So we see we are getting a lot over here. So this is our web page, and all this has just been generated from the user data section. So we need to get the details about the EC2 instance ID, availability zone, and private IP. I might not be getting that because with my section, it only has metadata version 2 enabled. So, but my user data script is using metadata version 1. Version 2 is just more advanced and more secure, but I can change that setting quickly and see how it works. So I'll go to the instance settings and modify the metadata option and say, instead of version 2 required. I'll say it's optional so that it uses the metadata version 1. Metadata is now data about the instance, things like which instance ID, which availability zone does it belong to. All that is part of metadata. So let me refresh this. And now you see I'm getting information, the EC2 instance ID, the availability zone, and also its private IP. So I will be using this same user data script for auto scaling, whereby just trying to, stress this CPU when we get to auto scaling. So that is our Linux server. And we also have our Windows server initializing. Should be passing the status check for now. And that is just our Windows machine. Now, let's get into the next section. So the instance types. We have too many choices, too many options. How do you choose an instance type which works for you? And what is the naming convention? Just over here, Kanye West or Kanye East in there. Don't mind me, but yeah. So we have different instance types tailored for specific requirements or specific applications. You as a user, you need to choose an instance type based on your workload requirements. And we have a naming convention of our EC2 instance. The one we launched was a T2 micro. What does T stand for? What does 2 stand for? What does micro stand for? So we have different instance classes, and and a T or a M in this case, this is M5 large. M will represent the instance class, indicating its category or family. So we have different families or different instance categories, and the first letter represents that. We have then followed by a number. Ours was T2. This is M5. 5 represents the generation, meaning that AWS continuously improves instance types over time. And then we have the last option. Ours was micro. This is 2 times large, which represents the size, making sure you are selecting the instance with the right balance of your CPU, memory, and network capacity. Now, getting into some of the instance types available, we have general purpose. And general purpose instances give us a balance, so it's just general. So we get a balance of compute, memory, and networking resources. And this can be used, for many diverse workloads. So the M family, as you saw, M5, M6, M8, you can see how the generation grows from M4 to M5 to M6 to, M7 to M8. That represents the generation. We also have the T family. T2 micro, the one we launched, belongs to general purpose. So use case, why would you use the general purpose instances? Applications that are built on open source software, things like application servers, microservices, gaming server, some caching fleets, all these are good use cases for the general purpose instance types. We have the compute optimized for compute intensive applications, which need very high performance processing. And now instances that are chosen for this category, things like batch processing, media transcoding, high performance web server, high performance computing, things like scientific modeling, distributed analytics, dedicated gaming servers, machine learning. All these require, very high CPU, or they are very compute intensive. And the C family, C going for compute. So the C family belong to the compute optimized instances. We have memory optimized, and now these require, good memory, right? So they are designed to deliver fast performance for workloads that process large data sets in memory. And we have the R family. I tend to believe it stands for RAM. So R family, X family, all these belong to the memory optimized. And good use cases for memory optimized workflows, memory intensive workloads. So things like open source databases, in-memory cache, real-time big data analytics. We are going to go for that. Storage optimized, we require to perform read and write. So high read and write access to large data sets on local storage. So these are optimized to deliver, good input-output operations per second. So applications that are I/O intensive are good for these use cases. So things like transactional databases that we have, we'll talk about databases in the next section actually. DynamoDB, MySQL, Postgres, or Amazon OpenSSH service. If we want to create that, then we'd go for storage optimized instances. And now we have the high performance computing, HPC optimized instances, whereby we want to get the best performance for HPC workloads. So any workloads that need high performance processors. And so things like, computational fluid dynamics, weather forecasting, molecular dynamics. So very high performance computing, not just compute intensive, but high performance. So the HPC instance types, belong under high performance processing. So speaking of just the M family, general purpose, we can see, for example, here the medium M8G. So the G stands for graviton processors, not required for the cloud practitioner level. But let's say the M8 family. M is general purpose family, maybe a medium instance here. 8 is the generation. So we can see the medium one offers 1 virtual CPU, 4 gigabytes of memory, and so on and so on. The large one offers 2 virtual CPUs and 8 gigabytes of memory. Extra large becomes more bigger, and 2 times extra large becomes more bigger capability. So 8 virtual CPUs, 32 gigabytes of memory. We also saw the concept of security group. I'll just go over quickly because we covered this in networking. So security group is a firewall for our instance, and they operate at the network interface level, so the ENI of our instance. If you want to go over, you can go over the networking module to get some of these concepts. Security group only have allow rules. So whatever rules we set are the ones which are allowed. Otherwise, anything else is denied by default. And we can restrict based on IP. So we can say which IP can access, maybe can perform SSH, or we can restrict based on, the destination or source IP address, including individual IP addresses and ports. So good to know about security groups. Again, an overview. We can link the same security group to multiple instances. A security group is restricted to a specific VPC, and it operates independently from the EC2. So the security group as our guard will block traffic. Now that traffic will not be seen as the instance. So it's good practice, just good practice, to maintain a separate security group for SSH. If you get any timeout issues, majority of the time, your instance is timing out, you cannot access your web server. Majority of the time, this is a security group issue. And all inbound traffic is blocked by default. So it does not have any inbound traffic, and all outbound is allowed for custom security group. How do we connect to our instances? So there are multiple ways in which you can connect to our instances. If you're using a Windows machine, Windows users, PuTTY is a common tool used to establish SSH connection. So you have to download it, and once you download and install, you can configure PuTTY with the key and IP address of the instance you want to access remotely. For the Mac and Linux users, Linux and Mac systems always come with OpenSSH, which allow you to SSH directly from the terminal. And then we have the Instance Connect, which is a browser-based version. So with Instance Connect, it's a quick way to connect through the browser without needing a private key. AWS temporarily uploads a key for the session, and you need to ensure that port 22 is open. So let's see how we connect to our EC2 instances. Back to our demo. So you need to have PuTTY downloaded and installed within your system. If you don't have that, you can just go and do PuTTY download. Download PuTTY and get the file. So download PuTTY and get the 64-bit file or installer and install PuTTY. So I have PuTTY installed within my system. So I'll just open it. When you open PuTTY, you get this tool. So the only thing you need is the IP address of your EC2 instance. So we'll go to the EC2 instance, our Linux instance. So this is for Windows users. Our Linux instance gets the public IP. So here it is. Open the PuTTY tool, paste the host name or IP address, and then we need to establish a connection. So under connection, we have SSH, auth, and we need to put our credentials. So we'll browse the private key file for authentication in this case, and the PPK file we had downloaded before. So PuTTY private key file, open and open. So this is the page you get. You're going to just say accept, login as. The default user to login as for Amazon Linux is EC2 user. And it authenticates and you are logged into your server. So you can now do any Linux command you want. So pwd, I am currently logged in as an EC2 user. I can, create files if I want to. I can, install some applications if I want to, and so on and so on. So that is how you securely access, a Linux server from the Windows operating system using PuTTY. For our Linux users and Mac users, you can do that directly using your terminal. So I'll just use the bash terminal of VS to demo this. So new terminal, but for you, just use your terminal if you are a Linux user. Okay, so it's loaded. So for OpenSSH, if you click connect at the top, you can see how to connect through the SSH client. So you need to change the permissions of your key file to just make sure it's not publicly viewable. You can get all the commands you need. So first you need to go to the folder which has that key file. So in this case, I need to cd to my downloads folder. So make sure you know your path. So for me, it's this. So in my downloads folder, I know my key file is in here. So if I ls, I know there are lots of content. Let me just ls .pem, all .pem files. Let me do long option to see the day they were created. Sorry, I did not download a PEM file for I did not download a PEM file for my machine. So if you want to do the conversion of PPK to .pem, we can always do that. Okay, so for Linux users, I did not download a PEM file. For you, you have to create your key pair and select a PEM file, but you can always do the conversion from PPK to .pem using PuTTY. So if you installed the Windows installer, you should have PuTTY within your system. So when you search for PuTTY, you just load your key, your PPK key. So my PJ demo, open and do the conversion. So I will export the OpenSSH key, just export it and save it as a .pem file. So it will be key2.pem. So this is the second key pair file. So pjkey2.pem, and once you're done with that, it downloads within your system. So I'm going back to my VS and list all my .pem files again. So now I have one that is created right now. So I need to change permissions for it to make sure only me has access, read access. So this is pjkey2.pem, and then I need to SSH into it. So the command, you can always find it over here. SSH into the instance using this key pair, the EC2 user at your specific IP address or DNS. So I'll copy that back to VS. Okay. Page into EC2 user PJ. The name of the file is key2.pem. Okay, EC2 user at your public IP or public DNS. So I can get my IP over here. .44 dot something. Yes. And now I am logged in. So using your terminal, this is how you log in as a Linux user or a Mac user. You need a .pem file. And now the third option, so that is the SSH option. We have the third option using EC2 Instance Connect, which is a browser-based version. So for example, over here, my Linux server, I can just say connect. And now instead of using the SSH client, I use EC2 Instance Connect. So you just need to make sure port 22 is available within your security group and just click connect from EC2 and you get access to the terminal just from the browser. So it's that simple. And yep, I am connected. So if I ls, you can see the file 1 that I created from PuTTY is still available. Okay, so how do you access a Windows server? So we use RDP. Those were the options for Linux. Now for Windows, if I want to connect to it, you need to have the RDP client installed. So I can say go to the RDP client. I want to connect through the RDP client. You will always get the option to download the remote desktop file if you don't have it. But since I have mine, now I need to get the password for my system. So I'll click get password, and now this is where I'll need the private key. The key that we downloaded is no longer used for authentication, but it's used to decrypt a password. So I'll upload my PJ Windows key, the one I created, the .pem file, open it and decrypt my password. So now I get a password. So I have my username, administrator, and the password this. So once you download your remote desktop file, you have to open the RDP client, remote desktop connection. And this is what you get. So I'm going to put the DNS name, the DNS of the public DNS of the EC2 instance. So this is this. So copy public DNS and continue, connect. You have been asked for your username and password. So the username should be administrator, not Pauline. So I'll go to more choices and say I'm using a different account. The username is administrator. The username is administrator. And the password we decrypted under this connect option. So I'll go back to connect. So I need the Windows Server Connect RDP. Okay, I need to upload my password again. So get password, upload the private key file, Windows key, open and decrypt. Okay, my password is here. And okay. So yes, I want to connect and my Windows graphical user interface is loading. Okay. So you can see I was able to, this is a different server. This is not my laptop or my Windows operating system. So it's the operating system of the EC2 instance. And you see you get access to just a Windows machine, a blank Windows machine that you can do with whatever you need to do, access the internet, and so on and so on. And that is how you remotely access a Windows EC2 instance. So let's get to the next thing, the instance pricing options that we have available. And what are some of the pricing options that we have available? So we have different pricing options for our EC2 instances. And the first one I'd like to cover is on demand. The instances that we created are on demand instances. Why? On demand instances offer flexibility with no long-term commitments. So we are paying by the second or for the only for the time the instance was running. So it's good for applications with unpredictable workloads or just very short-term projects. Maybe you have a development team working on a short test or proof of concept. So they can quickly start and stop instances as needed without any commitment. That is a good use case for on-demand instances. Think of it as renting a car. You are renting a car for only a short trip and you only pay for the hours or the days you're going to drive that car. That is on demand. We have reserved and reserved instances. Here we are talking about standard because we have another type of reversed convertible. So standard reserved instances, this we are reserving them. So they are ideal for predictable long-term workloads where you can commit to a specific instance type over 1 or 3 years. So you have to set up a 1 or 3 year commitment. And because you are committing to usage, you get some good discounts. So it's low cost. Now you get up to 70% discount, 72% discount compared to on demand. This is good for consistent applications. Think like something like a database or an ERP system. that they have to run continuously. So by committing to long-term usage, businesses save lots of costs over there. Now, in our analogy, you can think of it as leasing a car for maybe 1 year or more. That means that but with standard, we have to commit to a specific model. So if it's a Benz, I'm leasing a Benz for 1 year. If I compare that to on demand, I am kindly getting a lower monthly payment compared to someone who is leasing a Benz only for a day. Convertible reserved. So it has a smaller discount compared to standard reserved. So 66% discount, lower cost. But now this adds flexibility by allowing you to change the instance type. So this is good for applications with predictable long-term need. So you know you're going to need that application for a long term, but you are uncertain about your requirements in terms of maybe instance type. Something like a software as a service product might need more memory or more CPU over time, even though I know I'm still using the product for 1 or 3 years. So we are leasing a car in this case, but with the option to switch to a different model. So if my need changes, I can switch from a sedan to a SUV or something like that. And now we have savings plan. Savings plan, similar to the reserved instance, it offers 1 or 3 year commitment of usage. We can switch, so you can cover multiple instance types. But savings plans provide discounts based on a committed dollar amount of usage per hour. So you can say I'm using $10 per hour. So that is a commitment you have made. So this is ideal for businesses with a predictable spending, but you have variable workloads. And savings plan also works with different compute family types that we have. So you can switch to Lambda, maybe serverless if you want. So ideal for businesses with predictable spending. You know you are committing to a predictable spending per hour, but variable workloads. An example is a company may run some instance types for different applications. You can use a compute optimized instance type for batch processing, a general purpose instance for web hosting, all under one commitment, and you are getting up to 72% discount. So savings plans is kind of, the go-to compared to reserved. We have spot instances. Now, spot instances, very low cost, short term. They allow you to use spare EC2 capacity at a discount. But now, there is a trade-off. We are using a spare capacity. This instance can be terminated if that capacity is needed elsewhere. So this is good for things like batch processing, things like data analysis, or any workloads that can be interpreted. Something like a large data analytics job that does not require continuous uptime can run cost effectively on spot instances. So we are getting up to 90% discount. If we are thinking about our analogy, this is like renting a car at 90% discount, but with the understanding that it could be taken anytime if someone else says they want that car at the full price. So something like that. We have dedicated host. Dedicated host, they give you an entire physical server dedicated to your account. So you have full control over the server. And this can really help with compliance and regulatory requirements. So this is similar to like owning a car that no one else can use. So you have full control over the car and the privacy. This is ideal for organizations that have strict compliance requirements like healthcare or finance, or where you have specific hardware configurations that are necessary to meet your regulatory requirements. We have dedicated instance. This is also similar to dedicated host but this provides instance, the server, it's the virtual server on hardware that is dedicated to a single account. But unlike dedicated host, whereby you get your own physical server, AWS manages the placement within their own data center. So this is suitable for organizations that need dedicated hardware for compliance, so compliance requirements, but does not require full control over instance placement. So AWS manages the instance placement for you. It is simpler and a managed option for regulatory compliance. So it's like renting a car that only you are going to use again. So only you will use that car, but without choosing the exact location or something like that, or model. So all that is managed by AWS. So capacity reservation allows you to reserve instance capacity in a specific availability zone for any duration that you need. This is similar to reserving a specific car in advance for a trip, and they will ensure that that car will be available when you need it. So use cases for capacity reservation. This is good for businesses which have high traffic events or seasonal spikes. So maybe you have an e-commerce company and you are preparing for Black Friday. You want to ensure that there is sufficient capacity during peak demand. So by that, you'll reserve capacity. So those are the different instance pricing options. The other thing that I would like to cover is, the concept of elastic IP. High level overview. So I'll go over it quickly because we also covered under networking. And this is a static public IP. We are sharing the public IP. So when you create your EC2 instance, you get a public IP. For example, our Linux server. So let me go back to instances. And test our Linux server. So our Linux server has a public IP address attached to it. And when we use that IP address, we can quickly access the web page or the web browser. There it is. When we stop this instance, we are going to release our public IP. So anytime we stop, we will lose our public IP and get assigned a new one. So let's wait for a moment, wait for it to stop, start it again, and see what happens. Okay, our instance is stopped. So we can see we do not have a public IP address available right now. And we are going to start it again. So start instance. So it's in the running state and a public IP has been assigned. So if you remember, our other public IP was 44.244.255.66. Our new IP is 34. The other one was 44. So if I refresh this again, this will not be reachable because the public IP was released. And if I copy the new public IP, I should get access to my site. Okay, so the public IP changed. To prevent that, we can use an elastic IP, which is more of a static IP address. So how to create an elastic IP under network and security? You just need to say allocate an elastic IP and a static IP address gets allocated to you. And associate that elastic IP with your server. So I'm going to associate it with an instance, choose my Linux server and associate. So you can see the elastic IP is 54.214 in this case. So let's go and check our instance. and refresh this, and you can see it gains a new public IP. But this public IP is more of an elastic IP address, meaning it's static and will not change whether we stop and start this instance. So now refresh this will not work. We use the public IP address that we have. And it's loaded, so the new 54 IP. So if we stop this instance and start it again, we will still maintain our public IP, which is more of an elastic IP address. So elastic IP is a static public IPv4 address. Some of the good use case failover. If an instance fail, you can disassociate and associate the same IP address with another server. So we have the elastic block store, EBS, and this is what we are creating for our EC2 instances. Think of it as an external network USB drive you plug into your instance for storage that persists. So we call it persistent storage. It is not a physical drive inside the instance, but it connects through a network. So it kind of has a slight latency. So EBS volumes, they are locked to one availability zone. If you want to move an EBS to another availability zone, you must snapshot it. So create a copy and save the copy in another region. Encryption is also available for security, whereby and users pay for the provision size and performance. So when would you go for an EBS volume? You need persistent storage attached to one instance. Things like databases, application logs, or anything that needs long-term retention, because EBS is persistent. So data is kept even if the instance is stopped. We have the instance store. Think of it like the scratch pad of your instance. So it is extremely fast but temporary. Why? Because it's connected to the physical servers in the data centers. So it's directly connected to the server. That means that it's very quick compared to EBS, but it does not persist data. Why? Because if you stop an instance, then the next time you start that instance, it might be started in a different server. And if the storage is located to, is directly attached to a server, that means that you will lose that data. So data is lost if the instance stopped, making it ephemeral or temporary storage. So this is perfect for temporary storage and high speed input output needs. Things like caching, data loss isn't critical for you. So if your data loss risk is high, do not use it. So only use it for non-critical storage. So when to choose instance store? You good use cases, temporary storage for batch processing or caching, where you don't need data to persist after the instance stops. And now we have the final option, EFS. Now, EFS, think of it as a shared network drive. EBS can be attached to a specific server, even though when we go further in the course, we'll see like we can attach up to 16 EBS volumes to a server. For now, EBS, network drive that you can attach to a server, detach it, and attach it to another server. EFS, on the other hand, is a network drive, a shared network drive. So many instances, you can connect up to thousands of instances to the same shared folder. So it's like a shared folder on a company server. Now, EBS volume can only be attached to one availability zone. EFS supports multiple availability zone access, and it auto-scales based on the storage needs. So it's fully managed by AWS, accessible by up to 1,000 instances or more. It's fully managed and scalable. depending on the storage size, and works only with Linux instances. So that is really important. Yeah, so EFS is only attached to Linux instances. We have FSX for Windows if you need a file server for Windows. When to choose EFS? Perfect for situations where multiple instances need access to the same files, like a shared content management systems, things like WordPress, or data sharing applications. So a comparison between the three: EBS offers persistent storage, so go for EBS if you need secure persistent storage for your single EC2 instance, like for an application or a database storage that must be retained even after stopping and starting an instance. So it's with choose an instance store. It is not persistent. So opt for instance store for tasks requiring quick temporary storage, like cache or buffer processing, where data doesn't need to persist. And choose EFS for a scalable shared storage accessible by multiple servers across multiple availability zones. And it's great for applications with shared data needs, like content hosting or large data, large scale data processing. So that is an overview of EC2. Hope you understood something. Now, that is part one. In the next part, we'll get into scalability and load balancing. So on to the next one. Watch part two of EC2. Thank you.